polynomial, we're going to factor z squared minus 9. You can write that down, z squared minus 9. Now, just looking at the polynomial, what do you notice about the terms? About the z squared and about the 9?
No, it's not. It's a binomial.
It is a binomial. What do we notice about the terms, about the z squared? What is that?
It has a negative.
Okay, so our 9 is negative. Good.
It's not a perfect square.
Why not? What's
Because
wrong
I
with
have
it?
to multiply negative 3 and a positive.
Right, so the problem is while the number 9 is a perfect square, the number negative 9 isn't, right? Because I can't multiply anything by itself to give me a negative 9. All right, what about the z squared? What do we know about that term?
It's a z times.
It is a perfect square. It's z times z. Good. So in a previous lesson, we did similar to what we did in the warm-up, where we multiplied the difference of two squares. Like we multiplied a term, a plus b, times a minus b. So the numbers themselves were the same, but the symbol was different. One was a positive, one was a negative. And when we did that last week, we had an a squared minus ab. Then we multiplied here plus ab. And then the last term would have been minus b squared. And how did we go from this 4-term polynomial to this binomial?
The two middle terms cancel.
Yeah, our two middle terms actually combined to make 0. So even though they're kind of there, we don't show that. We can factor the same way. Last week we multiplied this way. You also saw it in the warm-up where Jordan FOILed out x minus 4 times x plus 4. She got the 4 terms and then she simplified and ended up with a binomial. We can actually factor this term here, this expression, and find out what two binomials led to that when they were multiplied. Okay. So could I rewrite each one of these terms as a number squared? Could I rewrite z squared? Could I rewrite the number 9?
Yes.
Z squared is the same thing as what?
Z times
Z times z. And what about the number 9?
3 times 3.
3 times 3. Good. And I'm actually going to go back here for 1 second because what we call this the difference of two squares. So if you look here at this image, do we have two squares?
Yeah.
Yes. Do we have the difference?
No.
What is different? What operation does difference mean?
Subtract.
Subtraction. Do we have subtraction?
No. You have a sign.
We do have subtraction, right? This would be the difference between these two squares. Right? If I asked for the difference between our ages, you would take your age and subtract mine, or my age and subtract yours, to find the difference between them. Okay. So if I rewrote this as z times z, and I rewrote this as 3 times 3, right, which we have right here, how would that help us factor? Think about if I was looking for two binomials that when I multiplied them through gave me z squared minus 9, what do you think the first and last terms would be? The first term would be a z, good, and what would the last term be?
3.
Oh, they would be a 3. We'll talk about the signs of those terms in just a second. If I wanted to use an area model and I wanted to work backwards, okay, I know that when we had created terms before, when we were multiplying, we ended up with the term broken out like this. We would have had the z squared and the negative 9. So how could this area model have helped us determine what the factors would have been? If these two terms are not here, what do we know happened with them? Like if I don't have anything in my final expression, they would have canceled out. They would have combined to make 0. So what two terms would have multiplied to give me a z squared? Good, a z and a z. Now I need two terms that would have combined to give me a negative 9 if I multiplied them. Which would be what? A positive 3 and a negative 3. Now take a look here. What would have happened if I multiplied the positive 3 times the z? And what would have happened if I multiplied the negative 3 times the z? So you can see here by working backwards that if you were able to find the square root of this term and the square root of the number here, just the number, not necessarily the negative 9, but the 9 itself, that you could have figured out what your two terms would have been. You would have had the z plus 3 and the z minus 3. How would we look at a problem like z squared minus 9 and even know that if I wanted to factor this, if I know that I have the difference of two squares, how straightforward would the factoring be? If you knew this is the difference of two squares, how would you factor it? Let's find the two binomials. Can you say in an easier, more straightforward way how we came up with that?
Wait, go back. Okay.
Like, how do I find the first term? How do I find the last term? Which kind? What are the two binomials that give me z squared minus 9?
Z plus.
The first term is a z, because if I FOILed,
Can it
I
be
would multiply
opposite?
z times z. And then what would have given me a 9?
Positive 3 and negative.
Right, a positive 3 and a negative 3. So really, you're finding like the square root of this term, the square root of this term. And what do you know about the signs?
They're opposite.
They would have to be opposite. Why?
Because you can't multiply 2 things together.
Say it again.
Because you can't multiply any numbers together negative 9.
So I know I can't multiply the same number by itself to get a negative 9. And what else about this indicates that I would have to have one number positive and one negative based on our final expression?
Because they're canceled out.
What's canceled out?
The plus 3 and the negative 3.
Yeah, that inside, that middle term, if I multiply through that whole binomial, those two middle terms eliminate to 0. The only types of numbers that would eliminate to 0 are opposites. Okay, so will one always be positive and one always be negative if I am factoring the difference of perfect squares?
No. Half. What if it was a plus 9 instead?
If it was a plus 9, is that the difference of perfect squares? No, that would have just been the sum. Right? So if we're specifically talking about the difference, will there always be one of the terms of the positive and one of the terms of the negative? Yes. So do the concepts work if you have a coefficient with your x squared besides the number 1? What are we looking for to indicate if this is in fact the difference of two squares?
Negative 1.
Okay, so it has to have subtraction. Good, this does. What else would have to be, Patrick?
Squares.
What do you mean?
The terms have to be perfect.
Both terms would have to be perfect squares. Are both terms here perfect squares?
No.
Yeah.
The 16x squared, is that a perfect square?
Yeah.
Is 81 a perfect square?
No. Well, yeah.
81 is, we're dealing with the difference of perfect squares. Okay, so in that, if that is true, how would this factor?
4x.
The first term would be a 4x. The last term would be a 9.
9 is a plus.
1 would be a positive, and 1 would be a negative. That's a weird looking 4, so I'll put that for you. So it doesn't matter if that x squared value, it could be another variable as well. It doesn't matter if it has a coefficient greater than 1. If it is a perfect square and we're dealing with the difference of perfect squares, we could factor it this way. How would I check it just to make sure that I did it right?
Foil.
Yeah, I could actually distribute it through and multiply if I wanted to FOIL. 16x squared minus 36x plus 36x minus 81. If I combine my like terms, these eliminate to 0 because they are opposites, and I would be left with what I started with, 16x squared minus 81. Now that one's sort of tricky because in its real foundation, that number, that 16x squared minus 81, it's not a trinomial, but it has the features of a trinomial. The difference is that middle term is really 0. So we don't ever represent a 0 typically. So that's why it's only represented as a binomial, even though it has the characteristics of the trinomials that we've been factoring. Alright, so I want you to try this one. Let's try, now you're already under the assumption here that that is the difference of two squares. Eventually you won't know what you're looking at if it is the difference of two squares, and you'll have to determine. But right now we know that is the difference of two squares. What would the two factors be? Okay, you have identified that the polynomial you're factoring is the difference of two squares. What are the two things that would indicate if this is the difference of two squares?
The minus sign.
There is, the sign between them would be subtraction, and both of the terms would be perfect squares. So do we have a perfect square, and subtraction?
Yes.
Yes, we do. Both of those would be perfect squares. So to factor that, I would take for my two binomials. How would I factor? Once I know it's a perfect, once I know it is the difference of two squares. What would I do? Square root of the first term, which would be 8x and 8x. So that would be the first term.
Minus the square root of the second.
And then the square root of the second term,
Plus 12.
which is going to be a 12 and a 12. And what about the sign? One is addition and one is subtraction. And really, again, we are still reverse foiling, if you want to call it that. We're really doing the reverse of the distribution. The difference is you don't see that middle term, that x term, because it eliminated to 0. But if you broke it out this way, you really could factor the way we had already learned, I mean, this would be kind of crazy, but you could find factors that would add up, and then you could break it up and do that whole thing. But there is a simpler strategy. And just to check to make sure, 8x times 8x is 64x squared. 8x times negative 12 is negative 96x. Positive 12 times positive 8x is positive 96x. And then 12 times negative 12 is negative 144.
8 times 12 is 96.
These terms would have been eliminated, write down, leaving you with the 64x squared minus 144. Okay. So that is actually the last additional type of factoring that you will learn for this unit. We have factored out a monomial from a polynomial, right, which is the greatest common factor. Right, then we transitioned to factoring a trinomial that had a coefficient of 1. Then we transitioned to factoring a trinomial that had a coefficient of greater than 1. Then we factored perfect square trinomials. And today we did factoring of the difference of squares. So there are 5 that we will continue to practice for the next few days, and that's what you'll see on your exam. In addition to the factoring, we learned how to multiply a monomial through and actually distribute, and we also learned how to multiply binomials by each other. That's the core of your exam. From moving forward, we need to start to identify what kind of factoring we're doing. Are we dealing with a trinomial that can be factored to two binomials, or are we dealing with a trinomial that we can only factor out a monomial? Those are the types of things that we're going to start to discover in the next couple of days so you can really keep track of all the different types of factoring we have.